Okay, continuing right along as we've gone through the params, I want to jump into the maths, which are a very interesting stream of things that you can use, and you really can get stuck on here. So what we spoke about before here was we were in params and we were looking at points, and I did suggest it's more interesting instead of importing a point from, say, the Rhino window into that node and dealing with that and then moving that around. Actually, let me just set the point this way. Um, should be set. There we go. And I can have control over that point afterwards. I'm just going to hit enter. That point can be moved around by the gumball, and of course it updates in the Grasshopper or ghosted image, but that makes you dependent upon a 3DM file. So what I'm going to do is delete that and say, why don't we skip the containers from now on and move on to something more infinite in its possibilities. So what I want to do is I want to jump into this point, and I will take it to display construct points, but I really think that's just too much information. And you can get rid of the draw full names and shrink it down so it's a point with XYZ attributes of output point. But I think I will prefer with full names because I like that information. I like my icons. And once again, you can group this with itself. And then if you find a need and you didn't want to bring in the bifocals plugin, you could just type in point and know exactly what that point's doing. And there it is as information. And I did say we were going to take a look at the graph mapper, which I thought you might find very interesting. And what's possible there is I can change out the graph types for things like parabolas. I can change it out for Bezier curves and have total control over that. And I can go in and set the domains to whatever numbers I want. And I can actually fine tune it while I'm in this editing section of it, which is pretty exciting. We'll get around to using that graph mapper, but let's consider what a point is. Points become very powerful in the math section when you start mixing that with sets because you start dealing with lists. And lists can then be played with polynomials and you can have some real fun with them. But let's take a look at what's in here. The two things I am going to borrow from sets right now, because I do want to get a little bit ahead of myself because we don't have much time left in this workshop, are dealing with series and dealing with ranges. And you might want to wrap your head around what that actually means. Ranges are wonderful because you'll have this kind of set. Series are wonderful because you have this sense of start, stop, start, step, and count to how many things you would like. And there's a bunch of defaults in here that I believe this one's set to 0, start area, 1 is the step, and 10 is the count. And your domain here is set from 0 to 1, and your steps are set to 10. So that will slowly start to make sense when you pull this out, because if I took this series and we zoom in on here, and we take our range and throw it into X, you can see that's exactly what it did. It just generated a double line list. And if I did the same thing with series, it's going to be a lot bigger because the step is 1, and it's not between 0 and 1. It's actually a step of 1 all the way up to 10. So you can see the difference between those two sets. So that's kind of nice. You can grab the one series and throw it in this direction, which is fairly interesting, and I'm not going to be able to get into tougher data structures, and there you go. It has a play. Now, one thing I'm going to throw in here just to throw everybody off with this little graph tool, we will deal with data as we get farther into it. It's very important for maybe in a more advanced class that you get into understanding your data structures. When I graph that, you'll see what I just made. It was a pretty incredible grid of points of 10 rows by 10 rows, so I should have 100 points here. Actually, I have 110 points because ranges and steps are a little interesting. You'll notice over here on the range, even though the series is outputting 10 locally defined values, the range is giving us 1 more. And that's a little bit of math we're going to have to play with within these steps. That will become interesting when we're dealing with list lengths and controlling our data. Not to confuse you too much with all of this, I'm going to basically take my range and I'm going to use my edit that out. I'm certainly not going to throw you for a loop with the graph and what's happening. We're going to take a look at the maths. In order to take a look at maths, ranges are, we'll skip the series for a second, but we're going to take a look at the range, which demands a domain. So what's happening here is we go to domain, a constructing domain. And I can take that domain, and there's a default 0 to 1, but this allows you to, and if I just take this over this way a little bit and shrink it down, this allows us to say, well, what would be our start? And I want my start to be an integer value between 0 and 10, and I want my start to start at 2. So I can go up here and I can actually take that point and pop it in here, and you'll see the range that I can slide back and forth in this direction. I'm just going to do a zoom extends all, so we're nicely centered on that. And you can see that I can have the ability to slide that back and forth to have its start point and its stop point to what's happening. So it's a wonderful way to grab hold of a line. The end, I'm just going to do a copy and paste and set my end way up to 10 and pull that into the stop of the domain. And there we go. We've got a range that's going from 2 to 10, and our range is outputting between 2 all the way up to 10, but it's split by the amount of steps that we've chosen. And at that point, you can grab one more number slider and set how many steps you actually want within that. You see the connection when you deal with a range with the domain to its start, its end, and its steps, how that relates to a series of a start, step, and count. And I will leave that up to you to play with a little bit. But what I want to do here is go in here, take a look at all of our points. It has that start at 2. I can jostle that back down to 1. I could have it start at 4. I could have it start all the way to 10. But you see how that has an influence on that line. And in order for us to visualize that line, since we're looking at creating a point, what happens when we start to do some funny things in the z direction? I will leave y so it's not wobbling out on the xy plane. I'm actually going to have it go up and down. And since we're dealing with this, a list of points, I'm going to go a little bit forward on curve and grab this wonderful tool called Interpolate. And you can actually go in here and grab some interesting ones like Nurbs Curves. And you might want to grab something fairly simple, which is a polyline right here. And you'll see the difference between all of these, which are really degrees of curves. This is a polyline, which is hard to make out because all the points are in the same on the same line, the x line, and this one would be hard to see as a curve, but you can see it going green here. The polyline is here green, and then you can see the vertices in the Nurbs curve. Now those all look identical, so it's very hard to distinguish them, but you'll start to see the difference in those when I play with the z coordinate. I may actually put it into the y. If I inputted this data into the y, it's just going to take it and slam it up on an angle like this. And so now you see, but once again, the polyline, the Nurbs curve, and the interpolated curve are all basically looking the same. So let's go back to something simple. Control and take out the y, and let's do something with the y list of points before I do it. Now I could go in there and say, okay, well I want y to step in one direction, step in the other, and this is where the maths start to play a very key role. The other things I do want to look at here as we move into surfaces, the other tool that I really want to now analyze, and you'll get into remapping and bounds and all these other things, and constructing and deconstructing planes. Divide do domain is one that I might want to come back to and have a little fun with a little later. I'm just going to tuck it maybe over here so I don't forget about it. And we'll deal with the surface in that. But right now we're just dealing with a single line created by points. So that shouldn't be hard. Now what could I do with the maths? And as I go through, we're not going to spend too much time on outputting matrices, but that's a wonderful tool to wrap your head around. The operators, I want you to pull them down and have fun with the additions, the divisions, the multiplication, the negatives, and the polynomials really start to become interesting. So what happens when I take something like, what do I want? A modulus, mass addition, mass multiplication, all these wonderful things. You'll get into some equality, larger than, greater than, if you want to do some conditionals and some programming. And I'm probably going to leave that for this intro, but let's go into the fact that we can just jump into these very interesting polynomials. Let's grab a square and say, what if we were to square all that data and put that into the y? Well, right there you start to see, because the number is very big, you start to see kind of the half, if I was to start this at 0, of a very elongated half of a parabola heading up there. And it's not the most exciting thing. It's there, but it is providing curves that they still remain somewhat the same. But you'll see the change from the polyline. It's going to be a little subtly different from the Nurbs curves as we move through these points. But still, it's such a subtle difference you're not going to notice. So let's skip the square and let's go into something a little more interesting, like logarithm. Logarithm functions are fairly good. Natural logarithm can be kind of fun. Pull that in here, and the reason I'm doing this is as I bring it in, you'll see I'm getting other strange curves. Now that curve itself might seem like something, what would I do with it? Let me pull it out of the y, and always use your right or left hand to think of x, y, z. We'll take that out of the y and we'll actually put that in the z. And what I've made is a curve that if I offset that off in this direction, maybe add to the x direction plus 2, or decide in my maths I physically want to move it by an integer value of, let's say, a slider 2 to 10, I can pull that into the x, and now I have the ability to slide that curve this way and that. And what happens is I can also come back and say, well, what happens if I create a very simple line, let's say a primitive of start direction and line, and say let's start a point at our vector, let's start it at 0, 0, 0, and just go in the z direction, and we're dealing with vectors here, and this is fairly, doesn't matter the length, it'll default to 1. It just basically needs an axis to actually revolve around. What happens when I take all these three curves and think about those points being generated? There's a little tiny line here that's indicated here. And what if I go to the transformations and have a little bit of fun and start doing things that I normally was doing in Rhino, but I'm having a little more control on that. So let's just go to a simple revolution. And I have to think, I think it's in surfaces. It's actually for creating surfaces. I'm just going to spend a little time on the revolution tool. It'll say, well, what curve do you want to take? And what axis would you like to take? And there you go. You've created a pretty interesting open bowl. And you could always, at this point, with what you've created, if you take a look at it, it's an untrimmed surface. We could take that, I believe, as a rep. Let's just double check. And let's get at the edges on here by a set list item, which I will go into details, and I like to get ahead of myself. That's a list length. A list item of the data that's coming out of the amount of edges. And I'm able now to take a look at how many edges there are, 3, so I could set a number slider for 1, ... to 3. And I would be able to roll through the list items to find out, do I want that curve, do I want the top curve, or do I want the bottom curve? And it's kind of subtle for you guys to see that, but it's selecting a green. It's selecting this set of curves for that revolution, the outer one, or the side one. So I'm going to go to the smaller one, and at this point, this is the surface that I actually want to close, and I guess I can just drag it into here for a surface, and I've got the little bottom end of the plate. So with that item, going back to sets, and I am getting a little bit ahead, and I don't mind it, I'm going to merge that data in with the revolution surface, and I have a plate that has no volume, but right now I have 2 untrimmed surfaces that if I take a look at what I'm actually dealing with, back to the panel, it will tell me what I have, and I can start to play with that geometry and decide I have a trimmed and an untrimmed surface which I can bake into Rhino. And they're actually on their own branches and different data, so I can do different things with each, which is kind of nice. So I have a list of lists. I'm going to continue with this because I'm just going to be playful with it. And I'll go into my sets tool and drop in a list and take a dispatch, which is like, I always think of dispatch as the first scene in Macbeth where he has taken the Earl of Northumberland and sliced him from knave to chops. And dispatching is kind of taking the head off of things. So let's go in here and put the list in, and I'm going to do something subtle here that takes the list on 2 items on 2 branches and flattens it. So I actually have one list with 2 items, and 1 item is heading over to A, and 1 item is heading over to B. And if I forget what I'm actually dealing with, this is a great time to pop back in your surface for this script containers, and I have to make sure that I'm dealing with an untrimmed surface and a surface. So let me just jump in here, and I might just grab a geometry instead of being specific to surfaces. And it says I'm having a problem. Fails to convert. Once again, you cannot put a panel between things and expect it to run. Some nodes will, but other ones won't. So what I was going to choose was 2 surfaces. And I should be very more specific because this will get you in the practice of naming what you actually are using when it comes to programming, if you get into Python or C the scripts. And now we have this surface and this surface, and with both of those I can start to do an extrusion from normals, extrusion from points. And I'm going to take the bottom and I'm just going to go to surfaces and a type of extrusion right here, and it should default in the Z direction, but if not, I will take it to Z direction. And what I want to do is show you a little other tool which is pretty amazing in the maths. For those that want to start doing their first mathematical expressions, go into the direction, go down to expression, scroll over, and let's make it x times, and we're hard coding this in, x times 2, and there you go, you have a base. But the other thing I want to do with this is the expression. I want to make sure it's not going in the up direction, it's going in the down direction, so I'll change it to negative. And you've done your first expression that if you take a look at this now, along with this surface, you've got another form of grabbing a merge, which I'm going to, you can cut and paste this, but then you have to disconnect all the wires. So that's a clumsy way of doing it, but it actually works. And now you have a base on this thing, which is parametric. And you actually can leave this, going back into the expression, just as a negative. So I'm off the page because I have multiple screens. I can go in here and just change this to negative x, and you'll see what I'm doing is playing with this And I can now put a slider on here and say, let's go from 0.200, and I'm able to slide that depth of the bottom of that to a very shallow, well, volume to 2 to 3, and I can alter the size of that plate at the bottom of it, which is a nice little technique to play with. Now, I haven't gotten into the complexities of making this for normals and extruding that. You technically don't need to too much, but you're going to find there's some complications. The other way I could do here is not put this code or script directly into the expression node here. I could have actually left that going up and just leave it as nothing, so it defaults to just x going in, and now my curve is going up into the top surface. That would make sense if I was to extrude the top surface in the z direction up. So I could take this one, bring it back here, and say, well, let's extrude that into the z direction, have that default in the up direction. There we go. We've got it actually matching, and bring that one in, and here we go. We have a little plate with a bottom that is fairly parametric to the thickness I want to go. And you've created something that you can bake in a Rhino, and you can Boolean union it and do other things with it once you're in there. I will take it and group it and send it in. I will leave my Grasshopper. I'll put this over into a shaded view that I can see it, and there you go. You've created a pretty simple script that is an interesting plate that would spend some time having to create and make out of clay. But let's go back in over to here and say, what's happening when we start to play with the maths that created that? We still are dealing with this curve that was coming off of here. So I can take my bake plate and literally slide it aside on my work table, have my next version. This plate is completely dependent on this point system of lists. And what happens when I start to play with that logarithm by going in and changing a little bit of the maths, going in and I enjoy this more than anything. I'm going to multiply this by, and let's just take a look at what numbers we're looking at. These are very small, strange numbers. So let's just go in here and think to multiply that data before sliding it into here. And that's not going to work because there's a 0 value. Let's take it in there and go for 1.00 and have a multiplication factor, which is literally a division factor. Back into here and see what we have and see what I can do to play with that shape. Interestingly enough, as I start to change this, it's really just softening and raising that. So it's not doing something too incredibly wonderful, but I'm going to go in and edit by rolling this up to 3, slide that up to 3, and there we go. We have a much higher vessel. And at that point, it's thicker, so I may want to go back in here and say, okay, since I'm using a list item here, a little quick technique here might be to internalize that because I'm not going to change that line. And then I can delete this, and just to double check that there's data in there I want, I can extract it and have a set number integer that's set there. So that's kind of nice little technique that you might want to pick up on. And at this point, I want it to be much thicker, and I'm thickening the bottom, but I'm also thickening the pot. I'm not extruding it in normals, but that becomes necessary when you start to deal with many different angles of where you can extrude. Here's our second pot. Let's take it in, and I will grab an extrude. I will grab a bake, and I will throw it into layer 4, and out it comes, and then I will take that and I will slide it back in this direction. And now I have another means to change this. Now for those that aren't really into maths, and you can see I'm getting into a multi-node system as I'm just being playful in the maths, and we're taking a look at operators, applying them when we can. You could apply logics to actually make things conditional. Polynomials are very interesting. I can transfer them to logarithm. I can work it from logarithm 10 all the way down to any natural logarithm I want. That gets fairly interesting. The other thing you can slide in here, and I'm not going to go into details of the evaluate expression, C#, GH, Python node, and VB script, which is where my real excitement is in Grasshopper currently, because this all tends to develop in creating your own nodes. I'm only suggesting that if you are going in here and you're not bringing in the nodes, like if I brought this direction and I wanted it to be negative, and I was used to going in and typing in something like, I'm just going to type in the node negative. And a technique I haven't shown you yet, if you don't know where that comes from, hold down Control Alt and push it, and these strange red arrows come up and circle exactly the tab maths of where the negative is. You can see it's tucked into the operators function, which means if I go here, I would have seen the negative right here. So instead of bringing it into here and typing it into the expression node, that's in the node, I can bring this in and slide this in, and now you'll find it goes in the other direction. So I have that one down there. So that's kind of an interesting technique to change it up. But if you're not going to visually do your nodes and you're going to start scripting, you probably will start incorporating the expression node and the function nodes. And if you're dare to go into that, you'll find the complexities of it jump right at you very quickly. And those are my true interests for the mathematician that's here in the room and actually wants to dig in deeper. And because of Daniel Kristev and his influence and being able to go here and script this way, this is a slow but sure path towards scripting in C# and Python and any other language that interests you. So if you make the effort to start to learn to manipulate these expressions, you'll start to want to manipulate the expression node, and you'll want to express the function node. And I think that's what they're called. This one's called evaluate. I call it function, but it's called the evaluate node, and this one's the expression node. And then you'll try a little bit of Python, you'll try a little bit of C, and then you're well on your way to seeing where that leads. It's quite a large forest of activity. So I'm just dropping in a lot of little tips as we're going through this. Now what I want to do is completely blast this out of the water as the potential of this. And the reason I wanted to show the graph mapper was this is all math. This is all wonderful ways of thinking with numbers and adding and working square roots and polynomials. And as we're at the 21-minute mark, and I do want to finish this kind of course up in the maths node, I've pulled from a couple of sets and list items here. I pulled from sequence ranges and maybe some series. We won't get into sets, and I'm avoiding getting into too much data tree structure. That would be much more of a second or intermediate level course of what we're doing. If you spend your time on math sets and then realize the power of vectors and creating the points we dipped into, you're going to know pretty much 90% of what you need to know in Grasshopper. If you can do, let's say 60% of what you need to know, if you can do 90% of what's within those three categories of math, sets, and vectors. And I truly believe that. It gets very simple, or it starts to move towards simplicity in my mind when I get into curves, surfaces, meshes, and then I'm always throwing in intersections, transformations, and then displaying things. But I did want to end with the visual power of going in here and saying, I want something simpler between those points. And I'm going to show a prime example of this and a wonderful example of this. I'm going to grab a whole bunch of graph mappers. And now I'm going to go back to the game of taking all this and turning the preview off. And we're going to focus on this. And we're going to do the same thing. Go in and create a point. I want my point to come from a range. And you can always type in range, and there it is. And if you forget where it actually is, hold down Control-Alt, and there you go. It blasts there. Put that into the X. We can cheat, in my opinion, and not deal with going in and creating a domain and putting it in there, because that's the same as actually doing that. But I can set the end of my domain, and I'll talk about this particular in the class, to something like an integer value of 12, which will allow me to go from 0 to 100. And now we have this ability to create this range of points that has a lot of power. And what I want to do as well is, even though the X is there, I wouldn't mind borrowing this little bit of math. And you could always do this. Well, let's go in and get in the practice of using this. Let's take the, it's not as fun to hard code things in here to the expression like 2 plus x or 4 plus x. You'd have to go in and change it. So that's where you want to go into the maths and say, no, I want the range to come in here, go into the x, but I want to be able to have a slider integer of moving it over in a direction like I did before. And I want it to come over quite a bit. And now I'm going to jazz it up in the z direction, but I'm actually going to use the power of this to run it through graph mappers. So if I run this into here, and maybe I'll just pull these down out of the way for a second, and I start to not want to code but graph this, I can start to do some interesting things with these points. And you're going to see there's a little bit of issues that my numbers are not matching my domain. I have a 20 domain here, and I have a 0 to 1 domain here. So to make this uniting and say I was happy with that amount of points or this amount of points, you're going to want to know that number. And this is the problem with the graph mapper, at least in my opinion, double-clicking it and saying, okay, we've chosen number 20. A good way to hard code that is to go here and internalize that data like I just did, and then extract that data. And what you've done is put in a domain that's going to run from 0 to 20. And then you can come here and hit your edit and take this up to 20. Let's just do that up to 20. And let's take this one up to 20. And we should have a little more jazz happening in there. And of course, I didn't mean to put it into the Y. I meant to put that into the Z. And now I have a very visualized system of how I can actually manipulate and transform this curve. And with the help of going through the same type of revolutions that I had before, taking all of this, and let's just cut and paste it. That's the power of scripting and liking what you did. And let's take these as the curves. And we'll go through. I took my point and I forgot to put it into my curves, which is a problem. I obviously can't do that. Let me choose a Nurbs curve. And I will, since I didn't use it there, I'll just bring it down here. I do like Houdini because you can shake nodes and the wires disconnect, but that's not a case with Grasshopper. I'm going to take those points, throw it through a curve, bring that curve into here, and I'm going to borrow that same axis that I had before, which is actually hooked up because I cut and pasted, the wires didn't come off. So technically, I'm going to take this, and I'm just going to throw in a little relay so I know exactly what I did. And now what I've done is as I go in here and turn on these nodes, preview on, you'll see I've produced a vessel that is much more, if I take these two and just try and get them out of the picture, well, I like them there. But if you take a look at what I've done is I've made a much more visualized system of changing and manipulating this before I do the extrusion. So this is where you can gain the control of building vessels and forms. And I kind of want to end with this after like the 2-hour session because we played off of a couple of nodes and got you interfacing. And I wanted you to realize that you can have an awful lot of fun of running graph mappers, not only going into here and changing the graph type to Gaussian, to go and then by turn changing this and manipulating that, having full control over a simple revolution tool by points. And interpolated curves and Nurbs curves, you can go in here, and the Bezier curves there, the sine curves there, but it starts to become very complex when you start to bring in multiple ones as you pattern this out. But what's also nice is you can take that and you can have multiple, like you'd have a sine curve on there, and then you could run it through a multiplication of a Bezier curve, and then connect that in the Z direction. You'll see what's happening, and that's actually a total flattening of what's happening. It's like not going to work, and the reason it's not working, and I can tell you exactly, is because I did not set my domain to the exact same of what it was. So I'll have to double click on here and bring that domain up to 20. So I'd want to cut and paste from the one that I made a change in. So I'm just setting my domain to match the domain that was on there. And that's one way of slowing down. You should be probably working smaller, but there you go. You've got the ability to run through a Bezier and have an effect on it softer to the sine curve and have some real effects. Now, if you want to write these as equations in the function nodes, in the expression nodes, or in the and I keep forgetting recently because I very rarely use that one. What was it? It was the expression node, the evaluate tool. I usually use the expression node, and I usually have my bifocals on. And this will be one of the plugins that I'll help people with if they specifically want it, because then you can see what everything's named and you don't have to name it. That's a nice little plugin that's worth bringing in. I think it's on some of these computers. Needless to say, that's it. I'm in here. I'm playing with graph mappers. What happens when I start to keep these along with the polynomials that I have and multiplications? The problem I don't like about this, or at least I remember about this, is if you close a script, I think these reset. So there is some visualization tools. I could be wrong. That might be fixed in Rhino 6 or Rhino 7, which is coming out. But that is kind of the tail end of the class as we're wrapping up 30 minutes. You've ended up generating some very interesting forms. You have incredible parametric control over them. You become to understand the canvas of Grasshopper. And I'm going to pull this one into 3 and see what color defaults, but it depends on my layers. And there's a lovely ugly blue. And I will get rid of what I can see in Grasshopper. I will take this over to render. I will close out my Grasshopper file. I should save it. I didn't close it out totally. I'll go over here and put it into my render. This one in the render. I'll put the other one in with the zoom extends all, which I told you guys to do from the start. Take this one into technical. Take this one into pen and ink. So it allows me a way to think of these drawings and also pull a lot of flat works off of here for reviews or critiques when it comes to liking or wishing me to do something different. And I always like a little artistic model here. And these are completely grabbable and translatable, and I did not mean to do that. And of course, an undo will not undo that. You have to reset your windows with the viewport, but there's some nice snapping tools here. Basically, I just wanted to bring this one back down to where it was and have it snap to the plane. So you've got this ability to take a look here, and we could go into details on rendering and all the other tools I like to do, except I think I've shut this down. Or maybe it's there and I'm just pushed off the page. I am pushed off the page. Let me slide that back in. And what's nice is when you end up making something you want, you can end with a very simple rendering exercise, which I will continue with this class for those that end up making something they want, and they can go in and say, okay, there's something that's decent there, those three forms. I like to make a quick little 300 dpi rendering of this, and I'll do a good quality. I'll set on a gradient color. I'll take off my skylight so it runs fairly fast, and then for my materials, I'll go in and say, listen, I want one to be a metal pot, colored. We'll do metal, and then I'll just go down and pick a color of, the passive blue I always like so much, just really faded. I can take a bump texture on that, dots, make it medium size, maybe large, and then I'll just hit set object, this one. And there we go, we grabbed a little blue. We're going to put it over the ray trace to see what it is. The next one, I'm probably going to add a material, have a little bit of fun with glass, run down here, pick a color, choose something complementary in the orange, kind of dark orange range, or something kind of grotesque, or happy or bright, or maybe yellow, or maybe keep it in a dark colors, kind of dark purple. Choose that one and set material to there. And there we go, we have a transparent glass, which you can't really appreciate in just this rendered mode, but the ray trace can't move around, so we'll just get this set first. And then I'll just grab something silly like paint. I'll go in and grab a color of some hot fiery orange or deep fiery orange or something like that. I'm not sure what I'll do. I'll be okay with that. And set one item. And because I have multiple poly surfaces, I might want to set the whole thing to that. Sometimes it's not good to group because then you'll just have to break it apart. And there we go. We have three little items. We'll set it up. We could always go in and see them in all our views. Zoom extends all. And we could take this one over and just do a quick click on ray traced. Oops, that's Arctic. Ray traced. And then you'll see that renders out fairly quickly. It'll take about 1,000 count for it to be where it needs to be. And maybe I'll just jump in here and show you that you've got these three little vessels. And you created those and you've made them parametric, and you throw in a little texture here and had a little bit of fun like that. It's going to take it'll reset every time you move in ray trace, which is kind of a pain in the butt. And I'll pull up my pattern again. And that's what you've ended up doing, making a dozen to 2 dozen nodes, having full control over what you're doing. I'm going to turn the previews off, put this down to here, slide this back over here. And you can see I'm still ghosting and playing with my forms that are coming out. And we have this final form that's here. And because we're in ray trace, it's not recognizing what shaded would recognize. And there it is. And at any time you can go in here and you can start playing again in not what you wrote in Grasshopper, but you can definitely play off of scales and do everything you used to do in Rhino. Have a lot of fun with that. I'm going to move that one out of the way, maybe over there. And I'm just having a little bit of running out of room because I'm a little lazy using multiple screens. We'll just slide that one over. And I still have a parametric model that I'm playing with, and I'm pretty happy with how that's ending up being. So you have your kind of glass, your painted, and your metal, and you still have a parametric model that's just begging you to get in here and visualize another type of shape and manipulate that and have some control over that. See, have some real kind of fun, kind of playful way of working it. When you think you have a set of stuff that you like, I wouldn't try this in ray trace, but just type over there. Have fun with the turntable. Have that rotate. And another thing you can do, which I like a lot, you'll have to take this off, but go in here and try the analyze. Grab yourself a surface, curve or zebra analysis, and there you go. You throw in a nice little finish of the metallic finish there. You can go into here and offset that with the analysis of the surface EMAP, which will turn it that kind of bean, Anish Kapoor bean color. And there you go. You can see the reflection of yourself within that one, which is fairly nice. And then for those that want to study curvature and such, we could go back and make a copy of this one if we wanted to. Just slide it over and tap Alt, which you might have learned already in Rhino. And with this one, we're just going to take an analysis tool and say, okay, well, let's do a little surface analysis tool on curvature and see what ends up coming up. And you end up getting this totally different kind of analysis of color of where it's awkward or in. It's actually pretty sweet. That said, that's a little bit of a workshop. This one went a little long in the end of 34 minutes. I think we kept it close to 2 hours. We'll have some playtime. We'll take off all these kind of analysis maps so it goes back to what it was. And hopefully you enjoyed that and you realize the simplicity of getting in and creating nodes and thinking about building your own geometries. Don't start with a solid, build that solid from surfaces, from lines, from points, and the attributes in math that drive that points. So the geometry that you once saw in your models is secondary and for the viewer front end, whereas your mind is much deeper and deep within the geometries and numbers and systems that are hidden within it that make and define it in a very pure and mathical and perfect and beautiful way. So thank you very much for watching. I am Michael Wickerson at Wickerson Studios, and I hope you enjoyed this workshop.